Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 81 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear. If you don't, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 80. But I must first ask, were you successful? If you got the homework done, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair, okay? Hopefully most of you guys got it, but if you don't, never fear. I will be showing you my solution today. What was the homework assignment? To have 3 LEDs, to blink the red LED asymmetrically at 1/10 of a second on and 9/10 of a second off. Then blink the green LED at 1 second on, 1 second off, and blink the blue LED 10 seconds on, 10 seconds off. And so what was tricky about it was to get that asymmetric blink using a timer in MicroPython. Okay, I really hope that none of you guys, switched over and used the second core. I really hope that you solved the problem using interrupts. Now, why was it a little bit tricky to use the interrupt? Because that period function on a timer calls a function every period, okay? But if you go up in that function, and if you put a time.sleep up there, then that will block the whole program. So you kind of get a little bit into a pickle as you try to do this. But like I say, I will show you my solution. So let's go over here and I will have you guys, I guess I should show you what the circuit is real quickly. Same as last week, we have 3 LEDs, red, green, and blue. The LED long legs on all 3 of these are pointing towards the right. And I've got the long leg of the red LED hooked up to GPIO pin 16. I've got the long leg of the green hooked up to GPIO pin 17. I have the long leg of the blue hooked up to GPIO pin 18. And then here, physical pin 38, I create the ground rail. And then the short leg of each LED comes to the ground rail through our handy 330 ohm resistor. So real easy circuit. You guys should have no problem getting that hooked up. So now let's come over to Thonny and let's see how we would do this. So let's just come in. And let's just jump in and see if we can start coding this thing up. So first of all, we're going to be using the GPIO pin. So we're going to need to import, or we're going to need to from machine import pin. We're going to from machine import timer. I know that you can do like pin comma timer, but I like to have each import explicit. It just, to me, makes the code more readable. Then we're going to import time. And now we're going to set up our pins. Red pin is equal to pin 16. Green pin is equal to pin 17. And then blue pin is equal to pin 18. Now we're going to set up our LED objects. Red LED is equal to pin of the red pin of the red pin, and that is a pin dot out, and then blue LED is equal to pin of the what? Not blue, red, green, blue. Come on, man, do it in the right order. Green LED is equal to green LED, green pin, and that is a pin out. And then blue LED is equal to the pin, blue pin, comma, pin dot out, like that. That's pretty neat, right? That's pretty neat. Okay, that's all working, or that's all typed in. I don't know if it's working or not. But now what are we going to need to do? We're going to need to define the define the red blinker, and I'll just do it the old way to begin with, and then we'll come in and fix it. But let's just kind of do what we did last week. So the red blinker is going to need source like that. All right, colon, and then we're going to do the red LED dot toggle like that. Okay, and then we're going to define green green blinker from source. I never know whether I should copy and paste or just bang it out, but I'm just kind of banging it out today. And that's going to be green LED dot toggle. And then we are going to have the define blue blinker source. Okay, and then that's going to be blue LED dot toggle like that. Okay, so those are blinking, and then we are going to come in and we're going to create our timer. So red timer is going to be equal to what? Timer. And then what is the period going to be? Let's just start it at period, and let's just make it, let's make it 1,000. Okay, and we'll come in and fix this later, but I just want to get everything working to begin with, and then we'll make it do what the assignment said to do. The mode is equal to timer dot periodic like that, and then the, get out of your way, callback is equal to what? Red blinker. The callback is red blinker like that, no parentheses. Okay, this time I think I will copy and paste. So we'll go V, and we'll go V. Okay, and we'll make this 100 milliseconds. We'll make this one 1,000. We'll make this one 10,000. So this is going to blink at 100th of a second, a tenth of a second, and 10 seconds. All right. And this would be, the second one would be green timer, and the third one would be blue timer. And then this is going to call the green blinker, and this is going to call the blue blinker like that. Okay, I think you've got what you need here. Okay, then we're going to come down here, and just to give this something to do, we're going to come in and we're just going to say X. We're going to say X equals 0, and then we're going to say we're going to then do our try and except try. Okay, why? Because we want to be able to cleanly exit the program. While true, when it's true, true is always true. Here's our main loop. And then in here, we're just going to say print X. And then we are going to say time.sleep of 1 second. Remember, time.sleep is in seconds, period is in milliseconds up here. Okay, and then we're going to say X equal X plus 1, like that. Okay, now what we want to do is we want to cleanly exit the program. So we're going to accept from the try on keyboard enter interrupt, and it turns that happy little purple color. And then what are we going to do? We're going to red timer dot de-init. We're going to turn it off, de-init, and then green timer, we are going to de-init like that. Blue timer, we are going to de-init like that. Okay, and then red, green, blue timer, then red LED dot off like that, green LED dot off, and then blue LED dot off. Okay, we got that program in. I guess we could have just copied and pasted. We could have copied and pasted, but it's not bad to just go back and review this stuff. All right, now let's hold our breath. Let's run this thing. And denied, red pen isn't defined. What kind of nonsense is that? Uppercase P. Like that. Okay, let's run this thing and look at this. We'll come over here to this view, and you see red blinking really fast, green blinking at 1 second, and then blue blinking at 10 seconds. Okay, that's sort of where we left off last week. But now, what is the problem? On this red one, I wanted it to be 1/10 of a second on and 9/10 of a second off. Okay, so now what is the problem? Well, you could think, oh, okay, I think I know what I'll do. I'll come up here to red blinker, and instead of toggling, what I will do is I will just say red, I will say red LED dot on like that. Okay, and then I'll say time dot sleep of, let's say, and this would be in milliseconds, so it would be 100, and then red LED dot off, and then I'll say red LED off like that, and then I'll say red LED, or I'll say time dot sleep of 1000. Okay, so then I'll do the timing up here in this function. So let me cleanly exit, Control C. You can see I cleanly exited. Now let me run this, and what you can see is this just got stuck. This didn't even do anything. So this just got stuck. And so probably what's happening is this period is calling this function before it even has time to finish. So it's like calling it. And so you can see that strategy isn't going to work at all. So let's Control C out of it. Well, what if I called it a lot less frequently? Like, let's say I called it every 1,000. So let's see what happens there. And Control C, it didn't like that. Okay, so time.sleep 100, time.sleep 1,000, period is 1,000. It just doesn't seem to like any of this at all. Okay, so what's happening? I'm calling it too fast. Well, what if I slow it down to like 2,000? Okay, let's see if we can do that. And you can see that I've kind of got it really confused because it crashed. I think what I'm going to have to do is unplug it and plug it back in. So it crashed, and I think it probably left one of those timers running. So let's restart it. Let's see what happens here. Okay. And then, okay, it seems to be working. So this is coming on and on and on and on. And again, the thing just seems to get stuck. So the approach that we are taking here is simply just not working. Okay, now what is wrong with what we are trying to do? Okay, and again, I think I kind of got it stuck again, so I'll unplug it and plug it back in. Okay, what I'm doing is I'm doing this deliberately to show you that you can't mix time.sleep. You can't mix time.sleep with your timer. So you see, this function is being called by a timer, and then this function is being called by a timer, and then I put a sleep in the middle of it, and everybody gets confused. And I hope you guys tried it that way, and I hope you guys found that that just isn't going to work. All right, now this is what I want you to see. You have to think about it, okay? So what? The red timer, okay, the red timer is going to happen every 1,000 milliseconds, every second. Why? Because I want the LED to be on for 1/10 of a second, and I want it to be off for 9/10 of a second. So 1/10 plus a 9/10 is 1 second, or 1,000 milliseconds. So the basic call to red blink, needs to be every second. Now what I need to do in here, you know that it doesn't work if I just say toggle, because what happens if I just say toggle? Okay, what happens if I just say toggle? If I just say toggle, it's on for a second, off for a second, on for a second, off for a second. Okay, what do I want? On for 1/10 of a second, off for 9/10 of a second. So what I want to do is, instead of toggling it here, let me Control C cleanly out of here. Okay, instead of toggle, I want to turn it on. Instead of toggle, I want to turn it on. Now, this is where you're tempted to do a time.sleep of 100 milliseconds. But you see, if you try to do a time.sleep and then turn it off, what happens? If you try to do a time.sleep and turn it off, then what happens? You end up making the program crash, and it doesn't like running a time.sleep. Plus, that time.sleep, even if it worked, it would become a blocking function. So what am I going to do? I'm going to create another timer, and I'm going to create it in here, and I'm going to call this one the red off timer, and that's going to be equal to timer, and the period is going to be equal to 100. Why? I only want the LED to be on for 100, and then I want to go where? I want to go to the callback. Okay, so I'm going to turn it on, and then I'm going to do my timing, not with the time.sleep, but with a new timer. And this one is going to be mode, wait for it, timer, and let me come here. Mode timer dot wait for it 1 shot. Okay, 1 shot, and then the callback is going to be equal to turn off, or turn red off, like that. It's going to be turn red off. So let's see what's going to happen. It's going to call the red timer, it's going to call red blinker once a second. When it goes to red blinker, what is red blinker going to do? It's going to turn the LED on, and then it is going to wait 100 milliseconds. This timer here is going to wait 100 milliseconds, and then it is going to call what? It's going to call turn red off. Okay, so now we come up here and we create a new function, which is going to be define turn red off, and we do the source because, right, it's a callback function, so we got to put the source in there. And then what do we want to do? Red LED dot off. Okay, now you might be tempted to put a 900 millisecond delay, a time.sleep 0.9, but you don't have to, because let's think about what's going to happen. This red timer is going to call red blinker. Red blinker is going to come here. It's going to turn the red LED on. It is going to then launch a timer that in 100 milliseconds will turn the red LED off. And now the red LED is off. You will not come back to red blinker. You will not turn red LED on again until what? 1,000 milliseconds have elapsed. So let's think about the timing. We go to red blinker, the red LED comes on, 100 milliseconds elapse. Then the red LED goes off, and then we don't call the function again for another what? For another 900 milliseconds. Then we've consumed the 1,000, it'll call it again, and then it will blink it. Could it really be that easy? We have a timer callback, call a new timer. But notice it's really important. You don't want this to just keep going, and you don't want to keep starting it. This timer one shot just means it does it one time and then it goes away. But that's okay, because the next time we come up here, it runs it again. And so basically this little one-shot timer, is giving me what? It is giving me the 100 milliseconds delay that I want. And then it hops up here and turns it off. But this does not work if you try to do this with a periodic function. Does that work? Well, I'm being kind of bold here because we don't know if this works or not. So I will need everyone to hold their breath. We will come back over here and we will have all eyes on the red LED. Hold your breath. Oh, D9. What's wrong with line 18? What did I do wrong? One shot callback. That was supposed to be a comma. Hopefully you guys saw that. Hold your breath. 1, 2, 3. Okay, boom. Look at that. Small blink. Small blink. So you see I'm on for a tenth, off for 9/10. On for a tenth, off for 9/10. And you see that's working perfectly synchronized with the green LED, which is simply staying on for 1 second and then going off for 1 second. And so you can see you've got your timing right, and then still the blue one is doing what we wanted. On for 10 seconds, off for 10 seconds, on for 10 seconds, off for 10 seconds. And so we got an asymmetric blink. How do you get asymmetric blinks or asymmetric pulses? You start the pulse by turning it on, and then you do a new timer, which is a one shot, to then go up and turn the thing off. Okay, guys, I hope that you're starting to get comfortable and familiar with these timers. I'll tell you, I actually think that when you really get comfortable with them, you'll start using them a lot more than a time.sleep, just because they're not blocking and you don't mess up any other part of the timing of your program. And so a lot of your time.sleeps, you could just go in and you could be doing them. You could be doing them simply by using these timers. Okay, I guess we need to talk about the homework, right? I think what I want you to do is I want you to have 4 LEDs, okay, 4 LEDs. And what I want you to do is with 4 LEDs and using only timers, I want you to make a binary counter using only timers. Okay, a binary counter using only timers. And what that means is that means in your while loop here, the only thing that you should have in your while loop would be something as simple as pass, not capital, pass. I want you to create the LED binary counter, the 4 LED binary counter using nothing but timers, okay? And actually, when you do that, you're going to find that's probably the easiest way to do an LED counter. Like if all of a sudden you wanted to go up and do 8 LEDs or 10 LEDs or something like that, that would be the easiest way to do the counter, would be by doing using these timers, okay? What you might do is you might you could do something like maybe if you wanted to print the value, like if you wanted to show the digital value on the screen for the binary number that is showing on there, you could do something like that if you wanted to. But basically, the work actually needs to be done with timers. Okay, guys, I hope you're having as much fun taking this class as I am making it. If you like the video, be sure to give us a thumbs up. It'll help us with the old YouTube juice. Also helps me show engagement if you'll leave a comment down below. That's always appreciated. If you haven't already, subscribe to the channel. When you do, ring that bell to make sure that you'll get notifications when future lessons drop. And as always, I want to give a shout out to you guys who are standing with me on Patreon. It is your support and your encouragement that keeps this great content coming. Thank you. Really appreciate you standing with me like that. Okay, and then as always, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.